Now, in a problem like this, I have fractions on both sides of the equal sign. And anytime I have fractions on both sides of the equal sign, I want to clear them by multiplying both sides by the lowest common denominator. In this instance, my lowest common denominator is 9. So I'm going to group everything on the left-hand side and multiply it by 9. And I want to multiply my right-hand side by 9. And when I do that, my fraction clears out on the right-hand side, and I'm left with 7. And I have to distribute this. Well, it looks like a question mark, doesn't it? I'm going to distribute this 9 to both w over 9 and the negative 6. Well, 9w divided by 9, I'm left with w. And I have to take away 9 times 6, which is 54. Now, w minus 54 equals 7 is a little bit easier to handle. So all I need to do is add 54 to both sides. And I'm left with w equals 61. That gives me my answer there. Okay. Now I see I have a variable k, and I have it on the left and the right hand side. Again, I don't care what side you put them on. I want to isolate the variables on one side and get all of the numbers on the other side. Notice how I'm talking about like terms here. I want all of my variables on one side and all of my numbers on the other. So I have 13k plus 5 equals k minus 7. Well, since my 13 is bigger than...
Athena Hartman, please come to the office, please. Athena Hartman, please come to the office.
Boy. So I want to subtract k from both sides to get rid of the k over here. And 13k minus k is 12k. And I'm going to leave this with my plus 5. And I'm left with negative 7 on the right-hand side. Now I want to get my numbers on the other side. So I'm going to take 5 away from both sides. And now I'm left with 12k on the left-hand side. And on the right-hand side, negative 7 minus 5 is negative 12. And now I can divide by 12. And divide by 12. And I'm left with k equals negative 1. Okay, for a problem like this, I can see that I have... variables on both sides, and they're within the parentheses. Now, whenever you have parentheses in an equation like this, we want to clear the parentheses first by distributing. So I'm going to distribute my 6 to both the 4z and the 2. And then I'm going to distribute the 3 to both 8z and 4. So 6 times 4 gives me 24z. And 6 times 2 is 12. And 3 times 8 is 24z. And 3 times 4 is 12. Oh, no. Hey, 24z plus 12 equals 24z plus 12. So when I take 24z away from both sides, excuse me, minus 24z on both sides, and I take 12 away from both sides, and I take 12 away from both sides, and I did 2 steps in one line. I hope you're okay with that. I end up with 0 equals 0. This lets us know we have infinitely many solutions. And here, whenever we get this, in math, we say that this is an identity. Okay? We will be tested on this word. So the word we use, whenever you get infinitely many solutions, we say that that solution is the identity. Alright, it's requested that I do problem number 58 and 59 from page 108 in your textbook. Here we're looking at problem number 58. 2 times a number plus 3 equals 1/2 of the number plus 12. Alright, so I'm going to start with this equals here. I see equals, I'm going to write an equal sign. So everything over here must be equal to everything over here. So 2 times a number plus 3. Well, that's going to be... anytime I see this a number, I'm going to use the variable x. And the number is referring to this same number, so that's still x. So 2 times x, 2, oh man, that was a terrible 2. 2 times x plus 3 equals 1/2 of this is multiplication. Anytime you see the word of, it's implying multiplication. So 1/2 of x plus 12. All right. So again, we want to get all of the numbers, all the variables on one side and the numbers on the other. So I can clear this fraction because I have variables on both sides. I could clear the fraction. I'm going to multiply everybody by 2. Multiply everybody by 2. I'm going to multiply everybody over here by 2. And I'm going to take that 2 and I'm going to distribute to this 2 and this 3. So I get 4x plus 6 equals, I'm going to take this 2 and I'm going to distribute it to this 1/2 x and this 12. And I end up with x plus 24. Because 2 times 1/2 is just 1. So 1x plus 2 times 12, which is 24. Now I should be able to solve this a little bit more simply. I'm going to subtract x from both sides. Subtract x from both sides. And I get 3x plus 6, that's an x, equals 24. And take away 6. And I'm left with 3x equals 18. And now I can see when I divide by 3, I'm left with x equals 6. Okay, so this is talking about somebody's personal jogging schedule. Now, they want to run 30 miles in a week, which is outrageous if you ask me. There's no way I would run 30 miles in a week. This person went ahead and logged everything that they've done up to this point. On Monday, they ran 4 miles. Tuesday, 4.5. Wednesday, 3.5. Now, they want to take 1 day's worth of rest, so I'm going to say Thursday is rest. They're going to rest on Thursday. And then they have 1, 2, 3 days left. So they have 3 days left. Let's see, there's all of these guys. There are 3 days left in order to get the rest of those 30 together. So we want us to write an equation that would model this scenario. Now, the total amount of miles that they want to run 30 miles that week. And they've already run 4 plus 4.5 plus 3.5 miles. They've already ran that much to begin with. And then they want to add Friday, Saturday, and Sunday to the mix, but we don't know how much they have to do each day. So, since there's 3 days left, then we're going to multiply that by the number of miles that they need to run in order to get to 30 total miles.